This conference will now be recorded.
Very good evening, students. Today will be
This conference will now be recorded.
hello dear students. Today we'll be discussing various numerical.
This conference will now be recorded.
Hello dear students. Very good evening. Today we'll be discussing various graphical problems from kinematics part. As you know, this is very important topics, kinematics, for various competitive exam. And you know, among the numerical problems, there are many important in themselves, but these graphical problems also are very important in this particular topic. So sometimes we feel these are easy, but we do a lot of mistakes. So today we'll be discussing a series of questions on graphical problems from the kinematics. So in the kinematics we'll be discussing with velocity, acceleration, then average velocity, average acceleration, displacement, distance, etc. Okay, and how we express various complicated motion in terms of graphs like distance time graph, velocity time graph, acceleration time graph, etc. We have learned already from the textbook. So today we'll be try to applying these concepts to answer the questions. Okay, so let us start with this question. So as you see, this question says a car starts from rest and accelerates uniformly by 4 seconds. Okay, that means it is accelerating 4 seconds by 4 seconds actually. Okay, 4 seconds. It is accelerating 4 seconds, and thereafter moves with uniform velocity of the xt graph. Okay, so uniform velocity. So which of the xt graph represent the motion of the car? So see, the car is accelerated up to 4 seconds, and thereafter the car moves with uniform velocity. That means acceleration becomes zero. Acceleration becomes zero after 4 seconds. So when there is no acceleration, what will be happening to the speed or velocity? Velocity will be constant. Okay, velocity will be constant. Look, or uniform velocity. So we have learned, see, if this is position and this is time curve, so constant velocity motion will be something like this. Okay, the velocity is velocity is constant. That means, see, the slope of this curve is always constant. This is, see, slope is actually dx dt or x by t. So this dx dt is nothing but velocity. So this remains constant actually in this curve. Okay, whenever there is a uniform motion, xt graph will be able to express it in this way. But if there is an acceleration in the motion of the body, like in this case from 0 to 4 seconds, okay, 0 to 4 seconds, it is accelerated with a constant acceleration or uniform acceleration, as you see here. Okay, accelerates uniformly. So whenever there is a constant acceleration, see here, this question is actually the graph between position and time. So position means I can take, or displacement I can take here, displacement. So we know displacement x is equal to x is equal to ut plus half at square, right? In this case, the car starts with initial velocity 0, so u initial velocity 0, then you know the acceleration time and the displacement has this relation among themselves. So x is equal to half at square. Now if I have to plot, see here, you know what we are getting, t square, or I can say this is x is equal to a by 2 t square. Okay, so this curve is, you know, this is in the y-axis. I am plotting y. Let us say this is y-axis y, and this is some constant a, and this is x. T is x. So what I get, let us say this is 4a. Y is equal to 4a x square. Okay, so y is equal to 4a x square, or so this you can see this is a parabolic equation, right? Parabola. So parabolic equation, but we have to understand that this is happening up to 4 seconds. Thereafter the motion will be uniform. Okay, uniform motion, okay, moving with uniform velocity. But here uniform velocity, whether it is negative velocity or positive velocity, that is not mentioned. Okay, first of all, look this portion, this is x is constant always. So after 4 seconds, if I say up to this is 4 seconds, then after 4 seconds, according to this option, after 4 seconds the body is not moving at all, it is at rest. But actually the body is then moves with uniform velocity. So this is not correct, because this portion is saying that the body is coming to rest after 4 seconds. All right, now come to this one. This is a parabola. So the parabola, this parabola will be actually like this. So if this is x and this is y, so 4a y is equal to 4ax. Actually the parabola will be kind of this. Okay, kind of this. Parabola will be like this. I can draw a little better like this. Okay, like this. Okay, this is the equation, this one. See, these two equations are actually identical, you can say. After comparing this, we can understand that this will be kind of this, but after 4 seconds, if suppose this is 4 seconds, thereafter it will be becoming like this. Okay, so this slope, see up to 4 seconds, if I say this is 4 seconds, so xt curve, this has got a negative slope. Negative slope means speed is not increasing, this is decreasing. I think both the curve are saying, I don't know what is the difference between these two curves. One more point is, say this is up to 4 seconds. Okay, up to 4 seconds. So I don't know, these two curves are looking almost similar to me. Yeah, hopefully there will be something anyway. But see, in this, see these two are not true, as you can understand that there is negative slope over here. Okay, up to 4 seconds. So this option 4 will be correct, because see this portion is there, this is uniformly moving, and since the here positive and negative nothing is mentioned, so we'll just take as positive. So this is the part after 4 seconds, and up to 4 seconds, see this is the nature. Okay, so that's how the fourth option will be the correct for this question. Obviously we'll look for this, like why this fourth or like first and second both options are same. We'll recheck that later. But anyway, the question was very good in terms of the conceptual understanding. Okay, how square graph looks like, etc. Okay, now let us go to the next problem. Yes, so what is this problem saying? This problem saying figure shows the position of a particle moving along x as a function of time. So position which is moving along x direction is a function of time, as you see here. Function of time. With function, position changes different ways. Okay, the acceleration of the particle is 0 in the region. So you have to show here where the acceleration will be 0. So there could be more than one region. So here in the option you look, this AB, BC, CD, and DE. These are the regions. Okay, the 4 regions are there. So among 4 regions, among four these regions, at which region there will be 0 acceleration. 0 acceleration. As you have seen, acceleration is equal to half. So kind of this. So this xt curve will be non-linear actually. So this curve will be non-linear, and this is where there will be actually, this is particle moving along x-axis. So let us take this as a, so there is a constant acceleration, we have to say. So here you can see, so at this position, this is uniform velocity increasing, and this is where there is uniform velocity but the velocity is decreasing. Okay, so what we have to answer is, we have to answer where there is acceleration 0. So where there is uniform velocity, there will be acceleration 0. So the portion AB represents uniform velocity. And option CD, like region CD, uniform velocity. Okay, but this non-linear region, see here, actually increasing acceleration. Okay, non-linear region, there is acceleration actually. Okay, so BC and DE. In case of DE, acceleration decreases, and in case of BC, in this region, acceleration increases. So the region AB and CD, they are actually having no acceleration. Okay, so AC is the answer. So option 2 will be the correct answer for this question. Okay, so now let us go to the next problem. Okay, so this problem is again an interesting problem. The question says the graph between the square of the velocity of a particle and the distance moved is shown in the figure. The acceleration of the particle in kilometer per hour. Okay, so here you have to find out acceleration, the acceleration of the particle in kilometer per hour, hour square. So What we need to do here, see, we know this velocity and displacement, right? Distance or displacement, whatever you say. So we have a relation v square is equal to u square minus 2as. So here the plot, see, if we for the timing consider that the particle does not start with initial speed, then this term I can cancel, and obviously there is a negative sign over here. So since this curve has negative slope, I am taking this as negative. So we have to find out what is the acceleration. Okay, so this is the acceleration. We have to find out that. Okay, so v square, we can actually take this. So actually v square by, see, this is actually minus half into v square by s, that is nothing but slope. So minus slope by 2. Now if we want to find out what is slope for this curve, this is a linear curve, so slope will be, see, delta s by, sorry, delta v by delta v square. Okay, slope. So slope of this curve is actually y by x or dy by dx. So this is actually 3 this and this. Okay, so this is the one, the slope. I'm not writing the like unit, so unit will be appropriate. I'm sorry, this slope here, there will be minus 6, 0.6 here, so 0.6 over here. Now see, what is the acceleration? Acceleration is actually, so this will be minus 2700 by this. Okay, so from here we can get 0, this. Kilometer per hour, hour square. Yes. So this is the option number C. Option number C would be the correct answer for this question. Okay, so this is again an interesting problem. You might be Like there is a very fair chance to do the mistake over here in this question. I'll just read the question and then explain how to solve this. Okay, so the question says in the figure, see the figure shows the position time graph of a particle moving on a straight line path. What is the magnitude of average velocity of the particle over 10 seconds? So what is the magnitude of the average velocity? So what we know average velocity? Average velocity is average displacement or displacement by time. Okay, so this actually this is dS by dt. So in this case, we have to find out ds by dt. dt is known up to 10 second. So dt is actually 10 second. And ds, what is ds? Okay, so what is the displacement over here? See, the initial position is at 60 and final position is at 40. Okay, so this is, this is 10. The displacement is actually so ds is actually 60 minus 40. I'm sorry, this is 20 meter. Then what is average velocity? Average velocity is 20 meter per 10 second. So this is 2 meter. Okay, 2 meter per second. We'll go to the next problem. So this problem is again an interesting problem. Let us try to read the problem and try to solve it. From the following velocity time graph, now it is velocity time graph. So the velocity time graph of a body, the distance traveled by the body and its displacement during 5 seconds, you have to calculate. So we have to find out this distance and displacement. So as we know, distance will be like geometry region. So the distance will be actually area under the curve. Distance or displacement, both cases. Area under the curve. Sorry, vertical. But in this case, one thing you have to remember, that when we calculate distance, we'll take all the area. Suppose here, this area, this area, this area, this area, this area, all the area will be positive. Okay, we don't have to consider the sign of the velocity, because you know distance means the total path length. But in case of displacement, this you have to take negative, and all other here will be positive area. Okay, if we do that, look, the see distance will be, see area under this part is half m, see half base into height, half base is 2 actually into height is 20 meter, plus this part is a square like a rectangle, this is 2 and this is 20, so that will be 40, plus this one is another rectangle, 1 into 20, so this will give you 20, and this, anyway I'm not writing half and all, so this will be 20 itself. Okay, so this part is half, see half base is 1, height is again 20. Now this part, now negative part is this much, see here half base is 1 into height is 40. So this is actually 20. This 20 cancels off. I think this is 40. So what we are going to get here, this is actually 70. I'm sorry, this is actually displacement. Okay, if this is displacement, okay, distance will be positive. This much will be positive. So what we have got, 20, 40, 60, 80, 90, 10 is actually this. What about this displacement? Displacement will be actually, so displacement will be, see here there will be minus sign, that's all. So displacement will be, so this 2 will be subtracted from the 2. I think I'm doing some mistake somewhere. Let me check where is the mistake. This is this. Okay. So in case of In case of distance, this 20 is added with this 20. So here it is actually 20, 40. Let me check. This is 20 up base. Okay, base is actually 2. Yes. So 20, then 40, then this is okay. This is actually positive here. So 80 plus 90. This is fine. Now if when this is minus, this will be 20, 20, 40. Okay, so this will be 70 actually. I'm sorry. This will be 70. Okay, so let us see the option here. See, option B will be the correct answer for this question. Now, this question is again very, very interesting. So, with this problem, what is the question? The question says a body is projected vertically upward from the surface of the earth. Its velocity time graph. How is it going to become? Say you are just throwing from here an object. Okay, so this object will move up to certain height, and momentarily it will be at rest at that particular position, and then its velocity, direction of velocity changes, and it comes to rest. Okay, this is what is the situation, isn't it? Like this. So the situation you have to see here, the question says the velocity, see with velocity, certain velocity it is thrown in the upward direction, so its velocity is going to decrease because it is going upward against the gravity. Okay, vertically upward means, therefore this is not true. This may be true, this at least up to this part. Okay, this may be true, but here also the speed is increasing, so this also is not true. Okay, so when you throw it, velocity start decreasing from here itself when g acceleration due to gravity acts. Okay, so this is not possible because it is going to be positive. In between it has uniform acceleration. So this is representing that the velocity will become 0 and then it will reverse actually. Okay, so velocity is, see, velocity will be in the other direction, negative direction in that case. So, but this is 3, it is always showing you positive direction. Okay, so option 2 will be the correct answer for this question. So in this case you have to understand that it actually decreases as it goes upward, and eventually at the highest point it will come to rest, then it will start again free falling due to gravity, and that time velocity will be increasing but in the opposite direction. So that's why it will pass through a 0, and after 0 it will be negative actually. Okay, so this is appropriate card because here see all the quantities are positive only, positive quantities, but this is not possible. Okay, so option 2 will be the correct answer for this question. Now, what is this question saying? This question is saying that for the motion of a particle acceleration time graph is shown in the figure. Oh my God. So acceleration time curve is shown in the figure. Okay, so this is actually acceleration time curve. This is shown or given in the question. The velocity time curve during 0 to 4 seconds. You have to find out what will be the variation of velocity during that time. Or if you see you have been given this acceleration time graph, you have to just find out velocity time graph. Okay, so now look this question. So like this figure, this is the acceleration. See, up to 0 to 2t, this is actually uniform acceleration, some a, so it is uniform acceleration or constant acceleration. So uniform acceleration or constant acceleration and with a positive value over here. So whenever there is a positive acceleration and uniform acceleration or constant acceleration, the velocity will be uniformly increasing. Okay, so look this card. This is actually indicating that it is uniformly increasing. Okay. Okay. So this is actually increasing slope as the velocity increases. Now we have to analyze the question, like answer part. So guys, here you look, you have to find out the velocity time graph from this acceleration time graph. If the acceleration varies with time like this, then how the velocity time graph will be varying. So first of all, 0 to 2 seconds, there will be constant positive acceleration. So velocity should increase uniformly. So when velocity is increasing uniformly, that means the slope of the curve should be constant. Look here, here the velocity up to 0 to 2, it is constant. So this graph is not true or not the correct representation of the velocity. See, because there is acceleration, right? But here acceleration is 0 according to this graph. Now let us go to the next. See this D option, up to 2 seconds. Let us say this is up to 2 seconds. See, acceleration is constant with a positive sign. So velocity should increase, but here velocity has negative slope. Okay, acceleration negative. It is showing acceleration negative. So this is also not true. Now come to C. So here up to 2 seconds, velocity is increasing. So it is actually representing positive acceleration. Okay, very nice. Now look, when acceleration becomes 0, suddenly it becomes 0 and goes to negative side. Okay, it becomes suddenly 0 and go to the other side. That means it becomes negative. So earlier it was pushing, increasing velocity, and now it is actually decreasing the velocity, or it is acting as the retardation. Like see, when you go like go by car, acceleration, like the car is accelerated, but at the necessity sometime you have to apply the brake to stop it, isn't it? So for that case you apply a constant, suppose constant this retardation. In that case what will happen, the velocity will try to like velocity will be decreasing, and suddenly, and after, see, if some if it had some velocity 80 km/h, due to this deceleration it will slowly decrease. Okay, slowly decrease, it will slowly decrease to 0. Okay, 60 to 40 to 0, suppose. Okay, so due to deceleration velocity should be coming to 0 from the maximum value. Then if still the acceleration is there in the negative direction, then velocity also will be increasing in the negative side. But in this case, look, as I said, this is not true, this D is also not true, because up to 2 seconds it should increase, this is showing decrease. Now C we had discussed, C velocity suddenly it cannot be 0 according to this graph. When the acceleration is going to the going through the 0, and after, see, after this 2 seconds it will actually start decreasing the velocity. So velocity start decreases, okay, decreases, and it will eventually go to 0 at 4 seconds, because see, at 4 second acceleration is again not there. Okay, I'm sorry, actually velocity will be become 0 because the deceleration is there. Okay, so 3 to 4 second, or 2 to 4 second, 2 to 4 second, this part is actually 2 to 4 part. The velocity decreases, okay, but it will cross 0, then it will be becoming negative. But in this case, look, at 2 second itself it is becoming like, so this is a kind of actually discontinuity in the curve. So this discontinuity is not true. So the velocity will be this much. Like this graph, velocity time graph will be like this, because see, when the acceleration was positive, now acceleration is negative deceleration. So this is representing the velocity time graph properly. At this stage it is positive, and this case has a negative. Okay, so option A would be the most appropriate answer for this question. Now let us see this question. A ball is dropped from certain height. So ball is dropped from certain height on the glass surface, the surface of a glass. This is glass surface, okay. It collides elastically and comes back to the initial position. So it collides and come back to initial position like this. Okay, so after collision it is actually coming to the initial position. So this is elastic collision. Okay, in elastic collision there is no change in the kinetic energy, so that's why it can go up to the initial point height. Okay, now you have to find out if this process is repeated, the velocity time graph will be like how the velocity time graph will be. Look then here, this is velocity time graph, this is velocity, all are velocity time graph. Now when the velocity like the ball is dropped from here, initial velocity was 0. Okay, drop means velocity, initially velocity was 0. Now look, this graph is not showing that initial velocity is 0, so option B is neglect, like cancelled or rejected. Now come to this one, or let us see this A. See, in case of A, see in this case, you know the velocity, if I take in the downward direction positive, while going upward it will be negative, right? So that will be change in the velocity direction. So change in the direction of the velocity, and that will happen just after collision. Okay, just after collision it will happen. So there should be change in the direction of velocity, but here see, these are changing the direction, but all the things are positive. Okay, all the velocities are positive, so option A I can reject. Okay, so these are actually positive, all are positive, so that's why I'm cancelling this option. Now among C and D, CD, see the ball has dropped, then here acceleration acts is the acceleration due to gravity, but the graph you see in the D is actually sinusoidal variation that generally be written for SHM and all. So in this case, you know, the acceleration is proportional to, so this is constant acceleration, but in other case acceleration is proportional to d2x by dt square. So in case of SHM, the acceleration has to be, say acceleration A is equal to minus omega square x. So omega square x. So it actually varies as acceleration varies as distance. So but in this case the acceleration is constant, it is not varying with distance. So I have crossed, see this one, this one, this one, like fourth one. See the second option I have rejected because the velocity initially will be 0, but here there is certain velocity. Okay. Option C you can see here. See, it will take certain time to come and hit the glass surface. So that's why this time this is hitting that glass slab, and thereafter it is actually changing its direction and go up. Okay, like I'm sorry, not go up. It is, yes. So changing its direction and go up. So in this case, you look, this is velocity increasing in the downward direction when dropped, and then eventually it will go to, see, just after collision it will be negative. Okay, so that's why this is the direction of the velocity becomes negative. Okay, here if it is positive v, here it is negative v. Okay, then at the maximum height again it will be 0 and then increases. So like that it is. So option C is actually representing the correct explanation or correct VT card for the, here if I say ping pong ball, that will be an appropriate example. So kind of a ping pong ball which is repeatedly colliding with the surface. Okay, now look this question. Here the question says the graph between position and time for a particle moving in a straight line is shown. During OA, AB, BC, CD, the acceleration of the particle are. See, during OA, this acceleration is actually negative. See, positive acceleration will be like this in the position time curve, like this. Okay. So 0 to A or OA, during this time acceleration is negative. And during AB, look, this is actually a straight line, kind of straight line. So there is no acceleration at all. In a straight line, there is no acceleration. So acceleration will be 0, AB. BC again, the acceleration is positive. Slope starts increasing. And then, I'm sorry. So initially it will be negative. Let us see this. Then it will be 0. Then it will be positive. I'm sorry. Then finally again it will be 0, because CD part, this that represents the uniform velocity, acceleration 0. Okay. I'll go to some more questions. See, here the velocity time graph of an object is shown. The displacement during 0 to T4. 0 to T4 is this much. During this time, say A, B, C, D. A area, B, C, and D. During 0 to T4, what is the displacement? Displacement has to be with proper notation. Like displacement here would be area under the VT curve with a proper sign actually. If it is negative, then negative. If it is positive, then positive. Okay, look here, the displacement. So this should be positive, this should be negative, this should be positive, D should be negative, E should be positive. Okay, so area A, area C. BD will be negative. BD will be negative. Let us see where BD are negative for the displacement. A, C, E positive. See option 2, area A, C positive, but area B and area D are negative. So option 2 will be the correct answer for this question. Now, which of the following velocity time graph shows realistic situation for a body in motion? So look, realistic situation means there will be a single value. So velocity should be single valued function of time, and also there should not be a sharp change. So changes should be smooth. It should not be like this. Okay, in real life case. Okay, so in this case, in this figure 1, look, if I draw a perpendicular like this, so for a single time there are two different velocities, value of velocities. See, this is the one. So this is one velocity, another velocity is this one. Okay, So this is not a realistic situation. So this is not a realistic situation. Now see this C, option 3. So as you see here, also the same situation will come. If you take like this perpendicular, you will get to see there are so so this can be is rejected. Both are rejected because this, you know, these are not feasible. Now look this option D. Option D, here also same problem will come. Now option 2 is correct answer for this question. So option 2 will be the correct option for like correct answer for this question, because here see the velocity, always there is a single value. Okay, so velocity is a single valued function of time. So velocity is a single valued function of time. So option 2 will be the correct answer for this question. I think I'll stop it here with this. In the next session, we'll discuss few more questions, and the questions I have discussed here now, these are all from different competitive exams like AIMS, and also from some questions maybe from NEET. Okay, kind of that. And I have few more questions to discuss. In the next session, I'll discuss the rest of the questions, and also probably I'll pick up questions from JEE Advanced and Mains also on this particular topic. Okay, only the graphical problems from kinematics I'll discuss in the next session, along with the problems we have in this slide also. Okay, so thank you for your patience. Bye for today.